Welcome to qnawire.
In this problem, we need to calculate for the angular velocity of the rod upon impact. So, we're looking for the angular velocity. So, I have here a sketch of the problem. So, a rod with a velocity v sub 1 strikes the corner point A. So, upon impact, there is an impulsive reaction from the surface to the end of the rod. So, as you can see in the second part of the diagram. So, this has components, x and y components. And then on the third part of the diagram, so immediately after the impact, the rod rotates about point A with an angular velocity omega, and the center of the rod G moves with a velocity Vg. So, before we start solving the problem, let's first convert some of the given values and solve for some of the quantities that we'll be needing in the computation. So, the length of the rod is given, by the way, so it's 30 inches. So, for consistency, since it's in inches, we will convert it to feet. So, let's write here, so L equals 30 inches. So, multiply it by the conversion factor. So, 1 foot is equal to 12 inches. So, cancel inches. So, this will be 30 over 12 feet. So, that's our L. And by the way, the weight of the rod is the one that's given, but we actually need the mass, so not the weight. So we'll calculate for the mass using the weight. So the mass is equal to weight over G. So the weight given is 5 pounds divided by the G, which is in feet per second squared, so 32.2 feet per second squared. So this is equal to 0.1553 pound second squared per feet. There. So, you can also calculate already for the moment of inertia. So, since this is a rod, its moment of inertia is given by I equals 1 over 12 ml squared. So this is 1 over 12 times the mass that we got earlier, so 0.1553 lb second squared per feet times 30 over 12 feet squared. So this is equal to, so our I is equal to 0.08089, so pound second squared feet. Okay, so these are our given values. So now we can write an equation for Vg. So since the rod rotated, we can express Vg in terms of R and omega. So, since point G is at the center of the rod, so it's at a distance of L over 2 away from point A. So, hence, Vg is equal to L over 2 omega. And since we know that L is 30 inches, so this is equal to 15 over 12 omega. So this is our equation 1. So we can write another equation. So we can write an equation for the moments about point A, taking the clockwise direction as positive. So our equation would be, so m v1 v sub 1 L over 2 sine beta, the angle, plus 0 equals, so I omega plus m Vg times L over 2. So, substituting the given values and the equation that we got for BG, equation 1. So, this will become, so 0.1553 times 8 times 15 over 12, then times sine 30 degrees plus 0 equals, so for the right hand side, our moment of inertia is 0.08089 omega. By the way, I'm omitting the units for simplicity, plus, so 0.1553 15 over 12 omega times another 15 over 12. So, simplifying the equation, the left-hand side would be equal to 0.7765. Then the right-hand side would be equal to 0.3235 omega. So, omega is equal to 0.7765 over 0.3235. So, this is equal to 2.4 radians per second. So, this is our angular velocity.